Hello everyone, today we are learning about acceleration. So first thing, please put your name at the top. My name's Miss Moronic. Please put your actual name, when this is due, and then what hour you have science class. So today we are looking at acceleration. We want to be able to measure and calculate speed and acceleration. Further, we want to be able to tell the difference between speed, velocity, and acceleration. So remember, we learned about speed graphs as well. And those ones were distance time graphs. So those ones looked like time, and then we had distance up the side. Now, a way that I always help remember this for myself is I just look at what is the speed formula. Speed is equal to distance divided by time. So a graph of speed is going to have distance and time. Now, today we're looking at acceleration. Acceleration has speed and time. So whenever you look at a graph, especially in this unit, the first thing you want to do is see and look, what does it say? What are our labels? So for this, time is still on the x-axis or the bottom. But now speed is on the y-axis or this side. Now this does make sense because our formula is acceleration is our final velocity minus our initial velocity all over time. Now remember, velocity is just speed with a direction. So that's where we're getting our speed to our velocity. Does this make sense? Yeah, we've got our change in velocity over time. And that's what this is representing, is what does speed look like over time. So a straight line on a horizontal speed time graph means the speed is constant, because if we say this is 5 meters per second, this object is moving 5 meters per second at second 1 and second 5. On a distance time graph, so if I look here and then if I draw a straight line, well, now we're saying maybe this is 5 meters, but over 5 seconds, it's still at 5 meters. So what's the difference on a distance time graph? The object isn't moving. Okay, so digging into this a little bit more. If we see a positive slope, this is representing an increase in speed because the object's accelerating. Over each unit of time here, we're seeing more and more and more speed. Now, when we see a negative slope, we're seeing a decrease in speed because there's less speed over each of these times. So if we said this is 1 meters per second, but then over here we're at 5 meters per second, that's a lot faster. If we're over here, this is maybe our 5 meters per second, and now we're down to 1 meters per second. So it's slowing down. So when we look at this on our graph, we want to match these up. Take a minute, pause the video right now, and give yourself a chance to match these up. Okay, and you're back. So let's look at these. Now you probably remember when we had a steeper slope, it meant that our object was on a distance time graph, could be going faster. Similar thing here is we're seeing more acceleration versus still acceleration, but not quite as fast. So A is going to be our steady acceleration. In relation, more of a gradual acceleration is going to be letter C. Now where do we see that constant speed? That's where we have our flat line, letter B. And then our deceleration, okay, process of elimination, but at the same time, D is also deceleration because we're seeing it slow down. So wrap up. The blank the line, the greater the acceleration. A blank line means the object's moving at a constant speed. A blank negative sloping line means it's slowing down. Take a minute, give these a thought yourself. Welcome back. So we should be looking, so from A to C, the steeper the line, I suppose saying more steep is probably better, but I like using steeper. The steeper the line, the greater the acceleration. A blank line means our object's moving at a constant speed, so our flat, straight, I even like to add a picture type of line is moving at a constant speed. And then a blank or negative sloping line means the object is slowing down, so like a down / downward. Now, something to keep in mind. Decelerating is also a type of acceleration, technically. And so if we have deceleration, we're going to see like a negative 1 meters per second squared. So another way to say this is it's negative. So technically, deceleration kind of is basically acceleration. It's just negative acceleration. More of a fun fact, because on the back side we might run into that exact same thing. Go figure. So, if the statement's true, write true. If it's false, change the underlined word or words to make it true. So, take a minute, look over these, and then come back. So, if we have a train slowing down, it's accelerating. Well, we just talked about this. So, if it's slowing down, this is false-ish. It's decelerating. Or more appropriately, negatively accelerating. But this is only false-ish because, well, accelerating, it's decelerating is a type of accelerating. So it's kind of false, but only ish. Because it kind of sort of is still acceleration. It's a type. It's just negative. So, number 2, find the acceleration. You must calculate the change in distance. No. The change in, well, velocity would be our best, but really what we put on the side here is speed. Now, why do we put speed instead of velocity? Is because when we're graphing it here, we can't show a direction on a graph easily like this because it's kind of all in there. So that's why it's like an outside factor. So speed is what we write on the side, but remember, speed is just velocity in a direction. Number 3, a Ferris wheel is turning at a constant speed of 5 meters per second, which means it is not accelerating. Is it or isn't it? If it is turning, it's changing direction. Now remember, velocity can change if it turns because it's a vector quantity. Acceleration is a vector quantity. Because we're having a change in direction, then we have a change in acceleration. So this one is also going to be this kind of false-ish because we have that change in direction. And then our last one, an airplane is flying west at 200 kilometers per hour. 2 hours later, it's flying west at 300 kilometers per hour. Is its acceleration 100 kilometers per hour squared? Well, let's do some math. So our formula, I do have it down here. I don't just have it memorized. You'll see that on any tester quiz we have as well. So acceleration is our final velocity minus our initial velocity all over our time. So let's set ourselves up. So an airplane is flying west at 200 kilometers per hour. 2 hours later, it's flying west at 300 kilometers per hour. So it's going in the same direction. We have 2 hours. The final is this 300 because that's what it's ending at least for this example. And its initial is 200. So now we need to put it into our formula. So we've got 300 kilometers per hour minus 200 kilometers per hour all over our time, which is 2 hours. So we got to do the math up here first. We get 100 kilometers per hour. 100, whoops, I'm falling off a little bit. 100 divided by 2 gives me 50 kilometers per hour, and it's squared because we've got an hour here and an hour here, and then we'll box that in. So is this true? No. It is 50 kilometers per hour squared, and we would want to put west to make this even more correct. So our next one, graph A plots a race car's speed for 5 seconds. What is the car's acceleration? So we've got 1, 2, 3, 4. So 5 is here. And then this is going up by seconds. It's in meters per second. So we've got 3, 6. It's going up by 3. So 24, 27, and 30. So I'm going to set this one up for you, okay? Our final, or where it's ending here, is 30 meters per second. Its initial, it started at 0, so it's 0 meters per second. And the time, it told us, was 5 seconds here. So we need to drop these in. We'd have our final minus our initial all over our time. I'm going to let you finish that one. Stick with me here. If you wanted to finish it, pause the video. I guess you could because you have that power. But graph B plots another race car speed for 5 seconds. Now on here, remember, here's our 5. It's still in meters per second. Here's our initial. Here's our final on here. So what's really happening there? Write those down. What is our initial? What is our final? When you get your final minus your initial, what do you get there? And then the very bottom, we're looking to match these ones up. So graph 1 is going to match because, 2 because, 3 because. Well, remember, we have speed here. We have more and more and more speed over time. Here, we have less speed over time. And here, we have the same speed. So if we say this is 5 meters per second, here, this might be, say, 5 meters per second, but then we're down to 0 meters per second. Over here, if we say we're at 0 meters per second and we're at 5 meters per second, hopefully that'll help you. So if you have questions, please let your science teacher know. We're here to help or answer questions. On your study guide, there are tons more. You might get a negative answer for some of your math problems, and that's legitimate. Just think, is your object speeding up or is it slowing down? If it's slowing down, you should get a negative number, and that's totally okay. Let your teacher know if you have any questions. Otherwise, have a great day, guys.